Next problem, solve d square minus 13d plus 12 into y equal to e to the power minus 2x plus 5 into e to the power x. The auxiliary equation is d square minus 13d plus 12 equal to 0. This is a quadratic equation. So you have formula to find the roots of the quadratic equation. Using that formula, d equal to 13 plus or minus square root of 169 minus 48 whole divided by 2. So after the simplification, here the two values are 12 and 1. They are real numbers but different numbers. See the case 1 in the procedure of a complementary function. So according to that, CEF can be written as C1 e to the power 12x plus C2 e to the power x, where C1 and C2 are arbitrary constants. So without forgetting, you must write the arbitrary constants. Next, particular integral pi is equal to, take the left hand side inside the bracket, that is d square minus 13d plus 12 to the other side. That becomes 1 over d square minus 13d plus 12. Okay, write the right hand side function given in the problem. There are two terms. Write the two terms, e to the power minus 2x plus 5 into e to the power x. So with respect to these two terms, we must write 1 over d square minus 13d plus 12 numerator e to the power minus 2x plus 5 into 1 over d square minus 13d plus 12 numerator e to the power x. Okay. So here both the terms, the functions in the form of e to the power ax. Therefore, our substitution is for the first term d is equal to minus 2. Okay, putting d is equal to minus 2, here the denominator is not equal to 0, we are getting the number 42. So e to the power minus 2x divided by 42. But for the second term, denominator is 0 when we are putting d is equal to 1. So observe, putting d is equal to 1, the denominator is equal to 0. Now you should write the equivalent formula. The equivalent formula, 1 divided by, okay, differentiate d square minus 13d plus 12 term by term. So when you are differentiating d square 2d, differentiate minus 13d, that is minus 13. Differentiate the constant term 0. So write 1 over 2d minus 13. Left side of this numerator x, right side of this the function e to the power x. So at any cost you should not change this order. Okay, the x must be left hand side of the 1 over 2d minus 13, e to the power x must be right hand side. Now put d is equal to 1, denominator is not equal to 0, we arrived at a number that is minus 11. Then general solution is y is equal to complementary function plus particular integral. Complementary function c1 e to the power 12x plus c2 e to the power x. Particular integral e to the power minus 2x divided by 42 minus 5x e to the power x divided by 11. Next problem, solve inside the bracket d cube minus 12d plus 16, outside the bracket y, put equal sign, e to the power x plus e to the power minus 2x whole to the power 2, the complete right hand side power 2. Okay, is it clear? This is little lengthy problem. I repeat, left hand side of the equal sign d cube minus 12d plus 16 into y, right side e to the power x plus e to the power minus 2x whole to the power 2. Complete right hand side power 2. Okay. So here in addition to the y term, dy by term, d cube y term, right hand side functions are given. Therefore this is a non-homogeneous equation. So the solution to the non-homogeneous equation is y is equal to complementary function plus particular integral. So first we go for finding the complementary function. For that, write the auxiliary equation. What's that auxiliary equation? Left hand side inside the bracket what you have d cube minus 12d plus 16. So write that and put equal sign 0. So auxiliary equation is d cube minus 12d plus 16 is equal to 0. So this is a third degree equation. One value of d must be calculated using the inspection method. What's that method? Put d is equal to plus 1 plus 2 or minus 2 plus 3 or minus 3, this much is enough. Okay. See whether the value, which value satisfies the equation. Here putting d is equal to 2. Okay, this d is equal to 2 satisfies the equation. See there, I got 0 is equal to 0. So therefore, by inspection method, now we arrived one value for d is equal to 2. So d is equal to is 1 root. To refine the remaining two values of d, we adopt the synthetic division method. I already explained. Anyway, once again I explained the synthetic division method. First row, write the coefficients in order. It means first coefficient of d cube 1. Next coefficient of d square. Here there is no d square term, so you must write 0. Next coefficient of d, that is minus 12. Finally the constant term is 16. Okay, put like L symbol. Left hand side is L symbol. The d value which you already arrived, by inspection method, that you write, that is 2 must be written. In the L symbol, very first column, second row, very first column, you must write always 0 to all the problems. Then add a first column, that is 1 and 0 add, we are getting 1. Right, as I shown in the problem. Okay, then multiply this 1 and with the root which you already arrived, that must be written second place of the second row. Add vertically, then write that number. Then multiply the number which arrived with the d value, that is 4. Write that 4 in the third place of the second row, add vertically. So we are getting minus 8. Multiply minus 8 and the d value which already arrived is minus 16 right in the fourth place. Add vertically, you must always get 0. Okay. Now we write the second degree equation, because what we are auxiliary equation is third degree equation. Now you must write the second degree equation. Okay, that is d square plus 2d minus 8 is equal to 0. Okay, see the coefficient of d square, d constant term are in the previous. See the previous step of 1, 2, minus 8 are there. So 1 is the coefficient of d square, 2 is the coefficient of d, and constant term is minus 8. So write the correct second degree equation. So it's a quadratic equation. You know how to find out the two values of d. So adopting the general method, d is equal to minus 2 plus or minus square root of 4 plus 32 whole divided by 2 equal to minus 2 plus or minus 6 whole divided by 2. So with respect to plus and the minus sign, there are two values for d. They are 2 and minus 4. Already we got one d value. Now two more values. So totally three values for d we arrived. They are 2, 2, minus 4. Okay, the three values of d for the auxiliary equation is 2, 2, minus 4. Now I write the complementary function. See, the 2 is repeated 2 times. For according to the rule, I must write inside the bracket c1 plus c2x outside the bracket e to the power 2x plus c3 into e to the power minus 4x. So complementary function we are right. Next particular integral. Write pi equals sign 1 divided by left hand side inside the bracket what you have that must be written in the denominator. So 1 by d cube minus 12d plus 16. In the question what you have in the right hand side that must be written e to the power x plus e to the power minus 2x whole square. Remember this must be written right side of 1 over d cube minus 12d plus 16 not in the left hand side. Then using a plus b the whole square formula. What is that? A square plus b square plus 2ab. Write the three terms. Write the three terms. With respect to the three terms, now what happened? 1 by d cube minus 12d plus 16 e to the power 2x plus 1 by d cube minus 12d plus 16 e to the power minus 4x 2 into 1 by d cube minus 12d plus 16 into the numerator e to the power minus x. Now we have three terms. For the first term, e to the power 2x is there. So put d is equal to 2. But what happened here? When putting d is equal to denominator is equal to 0. So I must write the equivalent formula. Equivalent formula is x into 1 by 3d square minus 12 e to the power 2x. How I got this 3d square minus 12? By differentiating d cube minus 12d plus 16. Okay. Then put d is equal to 2 now. When put d is equal to 2, denominators again 0. So I must write the another equivalent formula, that is x square into 1 by 6d numerator e to the power 2x. How I got this 6d? By differentiating the previous step 3d square minus 12. Now put d is equal to 2. I arrived x square e to the power 2x divided by 12. Already I told right hand side of pi there are two terms. Only the simplification part of first term is over. Coming to the second term, see in the second term e to the power minus 4x is there. So put d is equal to minus 4. Check what happened the denominator. Here putting d is equal to minus 4, denominator is 0. So I must write the equivalent formula. The equivalent formula is x into 1 by 3d square minus 12 numerator e to the power minus 4x. How I got this 3d square minus 12? By differentiating d cube minus 12d plus 16, okay, which is the previous step. Then Put d is equal to minus 4, what happened the denominator? So when d is equal to minus 4, denominator is 16. Therefore, second term is plus x into e to the power minus 4x divided by 16. Okay. So in the PI, simplification of right side first term over, second term over, coming to the third term. Okay. So in the third term, compare e to the power minus x with e to the power ax. We can come to know minus 1 is the substitution for d. Put d is equal to 1 in the denominator. So denominator is not equal to 0. We are getting a number 27. So 2 into e to the power minus x divided by 27. So at last we arrived a particular integral all the three terms. Then e to the power minus x divided by 27. So at last we arrived a particular integral all the three terms. Then finally write the general solution is y is equal to CF plus PI. Okay. CF is C1 plus C2x inside the bracket e to the power 2x plus C3 e to the power minus 4x plus particular integral is x square e to the power 2x divided by 12 plus x into e to the power minus divided by 36 plus 2 into e to the power minus x divided by 27. So there ends the proof. So we completed the general solution of the given problem. So we arrived the general solution.